You're talking about this N here. Yeah, that's a number of moles. That's number of moles. That's number of moles. Isandla sami siphuma fine la. No, isn't it Montlake? I would say my pictures it's fine. Marine camera unless it's just a regular. Okay, fine. In a high definition. In a high definition. Okay, right, are we done? Are we done? Can we do it together now? Okay, let's do the correction. So where do you start? You start here. You start by the ratio. MgSO4 is to water. You do your ratio. MgSO4 is to water. H2O. Ne? You do it as a ratio, just like what you did when you're doing empirical formula. Is that clear? Right. Now let's check our question. Our question, let me just go over the question here. It says magnesium sulfate is the formula MgSO4 NH2O. A sample containing 5 grams of magnesium sulfate was heated until the water had evaporated. The final mass was found. So the 5 grams is the combination of this. This is your 5 grams. So it includes your MgSO4, it includes the water of crystallization. Is that clear? Okay. I'll show you now. Right, then we've got the final mass was found to be 2.6 grams, final mass. So it means all the water evaporated. The mass that we have is now only 2.6 grams, right, without the water. How many molecules were in the original sample? How many molecules were in the original? How many water molecules? This question is it's a bit trickier. It says water molecules. Ne? It didn't say how many moles of water. There's a difference between molecules, number of molecules, and the number of moles. Is that understood? Right, let's analyze this. So let me go to the camera here, and let's see. Right, so the original sample had 5 grams. All right, it means including MgSO4 and the water. Is that understood? We heat this, and all the water evaporated. What remained? We remained with 2.6 grams of MgSO4. So the one that went into the atmosphere, that was the water that became a gas. So we need to find the mass of the water that evaporated. So what am I going to say? I'm going to say 5 minus 2.6 to give me how much? 2.4 grams. So 2.4 grams is the mass of the water. Yes. Yeah, go. All right. So the 2.6 plus the 2.4 must give me that total, which is 5 grams. Are you following? Yes. Yeah, but that final mass, what is that mass for? If we just take that 2.6, where are we going to put it? Because we need mass of water and we need mass of MgSO4. 2.6, it means we started with 5 grams. In these 5 grams, it was a combination of the water of crystallization as well as the MgSO4. Now when we heat, the water evaporates. Now the mass that is remaining, which is 2.6, that is the mass of only MgSO4. So what was the mass of the water that evaporated? We have to subtract original minus what left. The difference must be the water that left the system, which is the mass of water. Are we following? Right. Then what do? We do our empirical formula now. So it's going to be MgSO4. I'm just going to have to repeat this because I messed up by putting this masses here. So the mass, we're going to use this. Number of moles is equal to mass over molar mass. Right? MgSO4's mass, I know it, it's 2,6 over the molar mass. So I'm going to need molar mass for MgSO4. So I'm going to check on the periodic table. What is the mass for magnesium? Magnesium is 24 plus sulfur, which is 32, plus oxygen, which is 16. But how many are they? 4. So I times by 4. So this is over everything here. I'm going to put it in brackets. Is that understood? Right? You're going to get a single number. What is the single digit that you get? Okay, let me do the next one. Water, the mass of water that was in the system that evaporated is 2,4 over the molar mass of the water, right? It's going to be hydrogen is 1. How many H's do I have here? 2 plus 16, which I'm going to simplify. Right, which I'm going to simplify. I think there must be somewhere where I fine-tune this. No? It's a bit blurry. Do you see that? What do I do? Huh? Settings, whose settings? My settings. Which one? This one. Okay. Let me just call it. But okay, let's check. Last number. That's like the last number of this one. Doesn't it just needs a fine tuning? I'm not sure. It's a fine tuning. Yeah, I don't know where you. Let's go down and check. Flicker reduction. What's that?
Video quality.
Video quality. Let's see. We've got 480.
That's nice. No, leave it at 480.
480 is the best. I think 480 is the best. Okay. What else? Flicker. What's flicker? This. Let's try the 50. Flicker quality is, I think, when you're taking a picture, the flicking. Okay, let's see. What do you, yeah. What about this? PR Pro mode. Show advanced controls for. Let's see that. Okay. I'm not sure why it's not exactly clear, but there's a button here. I'm not sure this is for picture. No, not something. Nothing is happening when I press. Is it worse now? Okay, let's see this. What's this? What's this? Brightness. Let's see this. It's just brightness. Okay, what if I bring it closer? It's fine. No, no, no. Okay. Okay. All right. Switch to photo mode. I don't know what's this. Okay, we'll play around with it as we go, but you can see anyways. Okay, fine. Right. So this is what I have. So I'm going to have my 2,6. Some of you might have just a total. What is the total here? 24 plus 32. That gives you 56 plus 64. 56. How much? 120. So you'll have a 120. Yes. Yeah, it's fine. Your numbers are going to be different. Yes, it's fine. So you work with what you have. Yeah? Okay. Then you're going to have here, it's how much? 18. Right. Your answers. What answer do you get? 2,6 divided by 120. 0,02. Can I have 3 or 4 decimal places? 1, 1, 6. Okay. Then here 2,4 divided by 18. 0,1333. Right, so you just keep 4 decimal places for comparison's sake. Right, then you check which one is the smallest. Huh? The first one, which is 0,0216. Ne? That's the smallest. So we divide everything by 0,0216. You divide here by 0,0216. Right here, you're going to get a 1. And here, you get 6. 6 comma, is there 6 comma? 6 comma 1 6. I just want the full number before we round off, so people are not surprised here when we get a funny number that wants you to round off to the next number. 1 1 7. There are no numbers after 1 7. I need that number. 1 7 1 2, and so on and so on. Right, so your answer here, you're gonna have to round off this. You must round off this. Right, so you're gonna look at the digit here to nearest whole number, that becomes a 6. So your ratio 1:6. Therefore, your final answer becomes Mg SO4 dot that N. Where there's that N, now we've got a 6 H2O. Right, but have we answered the question here? No. The question says how many water molecules? How many water molecules? Are you following? It didn't say how many number of moles of water or how many moles of water. What's the difference now? We're going to go a step further. We looked at 2 formulas so far. We looked at number of moles is equal to mass over molar mass. That was the first equation for number of moles. The next one that we looked at was number of moles is equal to number of particles over Na, Avogadro's number. Are you following? All right, so we're going to use Avogadro's number because we now have number of moles. So this step might not be necessary. We need that 6 to connect it to number of particles. Remember, particles can be atoms, it can be atoms, it can be molecules, it can be formula units, depending what you're talking about. And here we are talking about water. Water is what is water? Water, we have got a covalent bond, so it's a molecule. Water is a molecule because it's made up of non-metals. Are we following? Right, so water is a molecule because there's covalent bonding here. It's made up of non-metals. Are we together? So water is a molecule. Right, so now we need number of molecules. So we're going to use this equation here, N, to find how many molecules are there. So what are we going to say? We're going to say N is equal to Na. Our number of moles, we're going to take that 6 that we got there. Are we together? All right, so here, since our 6, we're still going to use it. So it might not be necessary to round it off here. Ne? You can take that number that you have here because we're still going to use it. Are we together? It's not our final answer, the 6. So don't round off here, right? You can just take that 6,172 so that we don't perpetuate that error there. So I will take 6,17. We're using how many? 4, ne? So I'll take those 4. 1, 2. Those are my number of moles, right? Is equal to N, number of particles, over Avogadro's number. What is Avogadro's number? 6,022 times 10 to the power 23 over, right? That's your decimal. Then you make N the subject of the formula. N is equal to 10. Okay, then you cross multiply. You cross multiply, right? This is over 1, so you're gonna cross multiply. So I'm gonna have 6,1712 times 6,022 times 10 to the power 23. Your final answer. Someone on the calculator. You have to multiply. I'm not taking this picture here. It's something very much familiar. Yes. Yes. Which one? This one? No, you are wrong because this one gives you mass. It's going to give you the mass of the water. 3,716. Now I can round off, right? Because this is my final answer. We said 176. 716, which makes it 72 times 10 to the power 24 molecules. molecules. Yes, Rorisan. Avogadro gives you number of particles that are in that particular mole. How many particles do you have? Number of moles is just a quantity. It's like a dozen. How many dozens do we have? Like in terms of eggs, I've got 5 dozen. So now when you go to number of molecules, how many eggs do I have? So what am I gonna say? I'm gonna say the dozen multiplied by how many parts do I have in a dozen? You follow? Yeah. So moles is just like a global amount. It's like a global amount which we measure in moles. In each mole, there are Avogadro's number of particles. Those particles can be atoms, can be molecules, can be formula units, depending what you're talking about. Yes. Just like a car. How many cars do I have on the car park? I've got 10 cars. Now this question is asking how many tires do I have on the car park? Or how many wheels do I have on the car park? So I'm going to check on the car park. There are 10 cars. Each car has got how many wheels? 5 plus the spare wheel. There's a spare wheel. Okay. Right, so it's going to be 5 multiplied by 10. So I've got 50 wheels. If I'm going to take out the wheels, I'm going to get 50, including the spare wheel and the steering wheel. It's a wheel, Bella, okay? I just said wheels. How many wheels? Did I say tire wheels or I just said wheels? A steering wheel is a wheel. Yes? 2.6 over 120. I'm lost. Where? Oh, that up here. Okay. Yes. Come again.
10 minus 2.6.
Where did you get the 10?
It's for the mass of
where are you getting the 10? Let me check. Did you check the right question here? Because I think the 10 comes after this. Let's check. Where did you get the 10 here? Because here in the question we don't have a 10 here. Where are you getting the 10? Okay. Let me see. Let me see what you're talking about. Okay. Okay, you've got the salt, which is MgSO4. Or let me show you the camera here. Let me see what you're talking about. Let's check here. Which one are you talking about here? Where did you get the 10? Which salt are you talking about? Because I started with here, the total here was 5. So where are you getting the 10? How did you get the 10? No, where's the 10? I want that 10. Where's that 10? Yeah, so you can't come up with the 10. Why you didn't take 20? Why you didn't take 50? Why 10? Because what we were given was 5, so you have to use the 5. Okay, proceed. Let's see what you did with the 10. Okay, all right. Actually, what you're doing with the 7.6, that's what you're supposed to do with the 2.6. Number one, the 10 that you're using is not given on the problem, so you don't take 10. What was given was the 5. And why are you subtracting the 10 when we were given the 5? You have to say 5 minus. And the one that was left, the one that evaporates is not the salt. The one that evaporates is the water. So if I say 5 minus the final mass must be the salt that remains, because salt does not evaporate. What evaporates is the water. So you're not going to say 5 minus 2.6 and you get 2.4. Then you say 2.4 divided by the 120. No. because the 2,4 is the mass of the water that evaporated. You have to divide 2,4 by the water, by the substance that is evaporating. Are you with me, Johnson? Good. Right, so I think you are mixing your numbers. So don't take 10, use the 5, because we're given the 5. Yes. Someone? Yes? Shays. Yeah. No, it depends what you get. Sometimes it will be 20 to about 22, sometimes 10 to about 23. Depends how you multiply the numbers here. Yes, it depends. You find it on the calculator when you do that. All right, I'm gonna stop here for you guys to continue now working with the activity. If there are no questions, so please just point. I'll give it to you to take the nicer one. All right. What you need to watch out. You need to watch out for the problem. Is it asking for number of molecules or is it asking for number of moles? If it was moles, then you're gonna stop here. These are your moles, 6 moles. Are you following? But now it went a step further to say number of particles, just like how many cars. So you stop here. If it says how many wheels, now you need to multiply how many wheels are in each car by the number of cars. How many dozens? That's your dozen. How many eggs? I need to know how many dozens there are, and in each dozen there are 12 eggs. So I have to multiply the number of dozen by the number of eggs. Is that understood? Good. Right. I think if there are no questions, let's move on. You guys on online, you can always adjourn. I'm going to adjourn this meeting here. Then I'm going to post the handout on Google Classroom. You open Google Classroom, then you work from there. We have got about how many minutes left? We've got about 10 minutes left. So you can work through those 10 minutes. Please make sure you do the exercise 30, those who didn't do it yesterday, and also today's activity. Everything, we're going to revise it tomorrow. Any questions? Any questions? Right, if there are no questions, I'm ending this. You can take the picture. Okay.